Geo Center, top 4. Number 1. The crust.
The crust of the earth is similar to the crust of bread or the crust of a pizza. The crust is the outermost layer of the earth and goes down 35 kilometers. The crust is made out of igneous, metamorphic, and sedimentary rocks. The crust makes up less than 1% of the Earth's volume. The Earth's crust is divided between the continental crust and the oceanic crust. The oceanic crust is 5 to 10 kilometers thick and is composed of basalt, diabase, and gabbro. The continental crust is 30 to 50 kilometers deep and is made of slightly less dense rocks than the oceanic crust. Both the oceanic crust and continental crust float on the mantle, which cause tectonic plates to shift. Number 2 on Geo Center, top 4, is the mantle. The mantle lies between the crust and the core. The Earth's mantle is a silicate rocky shell with an average thickness of 2,886 kilometers. It is predominantly solid, but behaves as a very thick liquid. The mantle is made up of iron and nickel and makes up about 15% of the Earth's volume. In some places under the ocean, the mantle is exposed to the surface of the Earth. There are also some places where mantle rock has been pushed to the surface of the Earth by tectonic activity. Crustal recycling is a tectonic process by which surface material from the lithosphere is recycled into the mantle by subduction, erosion, or delamination. The asthenosphere is in the upper mantle and composed of plastic flowing rock of varying thickness, on average about 200 kilometers thick. Partial melting of mantle material is believed to cause incompatible elements to separate from the mantle, with less dense material floating upward through pore spaces, cracks, or fissures that would subsequently cool and solidify at the surface. Typical mantle rocks have a higher magnesium to iron ratio and a smaller proportion of silicon and aluminum than the crust. This behavior is also predicted by experiments that partly melt rocks thought to be representative of the Earth's mantle. In the mantle, temperatures range between 500 to 900 degrees Celsius at the upper boundary with the crust to over 4,000 at the boundary with the core. Although the higher temperatures far exceed the melting points of the mantle rocks and the surface, the mantle is almost exclusively solid. The enormous lithostatic pressure exerted on the mantle prevents melting because the temperature at which melting begins increases with pressure. The convection of the Earth's mantle is a chaotic process, which is thought to be an integral part of the motion of plates. Plate motion should not be confused with continental drift, which applies purely to the movement of the crustal components of the continents. The movements of the lithosphere and the underlying mantle are coupled, since descending lithosphere is an essential component of convection in the mantle. Number 3 on Geo Center top 4 is the outer core. The outer core of the Earth is a fluid layer about 2,300 kilometers thick and composed of mostly iron and nickel that lies above the Earth's solid inner core and below its mantle. Its outer boundary lies 2,890 kilometers beneath the Earth's surface. The transition between the inner core and the outer core is located approximately 5,150 kilometers beneath the Earth's surface. Estimates for the temperature of the outer core are about 3,000 to 4,500 Kelvin, in its outer regions and 4,000 to 8,000 Kelvin near the inner core. Eddy currents in the nickel-iron fluid of the outer core are believed to influence the Earth's magnetic field. The average magnetic field strength in the Earth's outer core was measured to be 2.5 millitesla, 50 times stronger than the magnetic field at the surface. The outer core is not under enough pressure to be solid, so it is a liquid even though it has a composition similar to that of the inner core. Sulfur and oxygen could also be present in the outer core. As heat is transferred outward toward the mantle, the net trend is for the inner boundary of the liquid region to freeze, causing the solid inner core to grow. This growth rate is estimated to be 1 millimeter per year. The fourth and final layer in our Geo Center top 4 is the inner core. The Earth's inner core is the Earth's innermost part, and according to seismological studies, it has been believed to be primarily a solid ball with a radius of about 1,220 kilometers, which is about 70% of the Moon's radius. It is composed of an iron-nickel alloy and some light elements. The temperature at the inner core boundary is approximately 5,700 Kelvin. Seismologists have found that the inner core is not completely uniform, but instead contains large-scale structures, such that seismic waves pass more rapidly through some parts of the inner core than through others. Because the inner core is not rigidly connected to the Earth's solid mantle, the possibility that it rotates slightly faster or slower than the rest of the Earth has long been entertained. In the 1990s, seismologists made various claims about detecting this kind of superrotation by observing changes in the characteristics of seismic waves. Estimates of the superrotation are around 1 degree extra rotation per year. Growth of the inner core is thought to play an important role in the generation of Earth's magnetic field by dynamo action in the liquid outer core. The existence of the inner core also changes the dynamic motions of liquid in the outer core as it grows and may help fix the magnetic field, since it is expected to be a great deal more resistant to the flow than the outer core liquid. There is an east-west asymmetry in the inner core seismological data. The western hemisphere of the inner core may be crystallizing, whereas the eastern hemisphere may be melting. This may lead to enhanced magnetic field generation in the crystallizing hemisphere, creating the asymmetry in the Earth's magnetic field. This has been a Geo Center Top 4.